Hello, today we shall see the circuit of inverting amplifier using operational amplifier IC741. We are using IC741 particularly because this IC is recommended by HSC board as well as by universities to perform different experiments of operational amplifier on this IC. So we are using this IC in particular. Now we shall just understand the setup first. This is the switch which can be used to flip the value of R1 from 3.3 kilo ohm or up to 4.7 kilo ohm. If I press this switch in this position, then the value of R1 will be now 4.7 kilo ohm. This is input resistance and this is feedback resistance. First of all, we shall keep it in 3.3 kilo ohm. Here is the input voltage which will be connected to inverting terminal of the operational amplifier and the ground line. The offset null adjustment is internally done inside this IC, inside this board, and along with that we are connecting dual power supply over here inside this circuit. This is the input voltage adjustment knob with which we can change the input voltage. If I rotate this knob anti-clockwise, then the input voltage can be set to some negative value. If I rotate in clockwise direction, then the input voltage will be positive. Here we are getting the output voltage. So let us see now how to do this. I am using digital multimeter and I have set the range to 200 volt DC so that I will get just single decimal point over here. It is not necessary to go for higher decimal point values because we just want to know that whether this circuit works as inverting amplifier. Now since our input resistance is 3.3 kilo ohm, naturally the gain of this circuit will be, I shall write down the equation here, the gain of this circuit will be simply RF upon R1. So that gives us 10 kilo ohm upon 3.3 kilo ohm, that is equal to 3.03, means this is our right now the gain of the circuit. So let us see how to perform it. First, connect the negative terminal of this voltmeter to the negative rail. This is ground line and I connect it over here so that I can measure the input voltage. It is right now minus. I shall set it to some positive value. So make it as say something like 1.3 volt. Now when input voltage is 1.3 volt along with the gain of 3.03, let us see what is the output over here. First you can see that the output voltage is negative because we are using it as inverting amplifier and the output voltage is 3.9 volt. When the input voltage is 1.3 volt, the output is 3.9 volt. So let us see whether it works properly or not. According to our equation here, gain is given as 3.03 and we are applying input voltage Vi is equal to 1.3 volt. 1.3 volt. So input voltage is 1.3 volt and we are getting the output voltage here as 3.9 volt. So VO is equal to 3.9 volt. So the gain will be actually, the practical gain of this circuit will be 3.9 upon 1.3 will give you exactly 3. So our actual gain according to the values of RF and R1 is 3.03 and practically we are getting the gain as a 3. So our experiment is working quite perfectly. We shall change the input voltage to some negative value and let us again repeat this experiment. Here our input voltage right now is minus 2.2 volt. Let us see what is the output coming up over here. It is 6.7 volt. I again check it. 2.2 volt minus we shall write it down over here. Input voltage is 2.2 volt with a negative sign because our input voltage is negative, and the output voltage that is coming up over here is 6.8. Output voltage is 6.8 volt. So again the practical gain will be 6.8. We shall write down the gain over here. Gain is equal to 6.8 upon 2.2, that gives you 3.09. So again the gain is almost equal to our practical gain according to the values of RF and R1. So in that way we proved that the circuit can work as inverter, means change the sign of input voltage to positive voltage if input voltage is negative, and if the input voltage is positive then the output voltage will be negative. We can repeat the same experiment in this position also. Now the value of R1 is 4.7 kilo ohm. So the gain will be how much now? We have just seen here. The gain will be, the gain is equal to 10 kilo ohm upon 4.7 kilo ohm, that gives us the gain of 2.13. So let us consider this gain according to the ratio of RF and R1. Now let us see whether it satisfies by measuring the input voltage values. I change the input voltage here. Input voltage right now is 2.4 volt with a negative sign. I write it down here. VI is equal to negative 2.4 volt. And let us see what is the output coming up. It is 5.2 volt. So VO is equal to 5.2 volt positive. Okay, so the gain in this reading will be how much? 5.2 upon 2.4, that gives you 2.166. So again the gain is almost same, and we have in this way showed that the circuit is acting perfectly and it is working as inverting amplifier. We can again check the last reading. I make the input voltage as positive. Say I change the value to something, say 1.1 volt is our input voltage with positive sign. I take here the values. VI is equal to 1.1 volt. 1.1 volt. I again check it. Yes. And the output voltage right now is minus 2.3. Output voltage is minus 2.3 volt. So the gain will be how much? The gain is equal to 2.3 upon 1.1. So that gives you 2.09. And our actual gain that we calculated according to the ratio of RF and R1 was 2.13. So again the values are almost same. So with this we proved that the circuit really works as inverting amplifier. You can use the reference of our practical handbook by referring to this experiment given in our practical handbook, and write down the observations in the observation table and do the necessary calculations to get the proper output and to prove that the circuit really works as inverting amplifier. Thank you.